All right, everyone. Welcome to Build Your Data Science AI Agents. I'm happy here to be joined by my three lovely co-speakers. My name is Shu Xing. I have a PhD in economics. I now work at JP Morgan. I'm also a community lead at AI Camp and Women in Data Science at New York City. I love running and cycling. You can connect me on Strava if you want. Everything I say is today is my own and doesn't represent my own company. Next, Asta.
Hi everyone, I'm Asta. I'm a senior data scientist at CVS Health. I've been with them for 2 years. And outside of that, I'm also the founding vice president of WPDU, or Women Who Do Data, where we support women moving into tech or pivoting their careers into tech. And when I'm not doing all this, I'm fostering a lot of cats. I've done like 20 plus now. I have one at my home right now. His name is Ace. If anyone wants to see his photo, come meet me after. And anything I say today is my own opinion. Anything I present is my own opinion. Like nothing represents my employer or my company. Okay.
Moving forward. Hey everyone, I'm Niharika Krishnan. I'm a machine learning engineer. I work in the intersection of quant finance and AI. I run the PyLadies New York chapter and the Women in Data Science along with these lovely ladies. Love playing board games, huge adventure lover, again repeating all thoughts and views and code, and everything in this talk and tutorial are my own and do not represent my employer.
Hello, my name is Michelle Rojas. I'm a backend engineer and have been for the last 10 plus years, some full stack. I am also in the WIDS organization, Women in Data Science. And I'm also an organizer for the Rust NYC. If anyone likes Rust or likes NYC or likes both, please come talk to me. I also like volcanoes. I go to one every year for my birthday. That's a picture of me in Costa Rica. Dragons, $5 in the last 10 years, all about dragons. And then open telemetry. A big passion of mine is monitoring and observability. And so that's me. And now the tutorial.
So we'll try our best not to make you guys fall asleep now. So about this tutorial, So we have a small overview of AI agent and its use cases. The talk is mostly focused on the hands-on workshop in building an AI agent for data science. And then we'll have also Michelle to teach us the understanding of its deployment, evaluation, and challenges. So let's dive in. We cannot start with a talk without a graph since we're data scientists, we're at PyData, right? This is a Google trend of AI agents versus large language models, and you can see that large language models start picking up with the start of ChatGPT, but AI agent is really just picking up at the end of last year, and now everyone is talking about it. So 3 years ago, we started from a prompt or a question to the large language model, and we now have a lot of options now, and then we're getting an output from the large language models. So that's what we have been doing for a long time. And then to age, we're sort of like, okay, how do we make LLM do things for us instead of just having a chatbot? So we get to a point where AI agents starts becoming popular because we want our large language models to have access to memories, whether it's short-term or long-term, or databases of your company, or we want it to access tools such as different APIs, functions, and databases, and so on. And we want the AI to figure out orchestration on its own. Why is it always coming on and off now? Figure out orchestration using different frameworks like React and so that's how we have gone from large language models to agents in the last 3 years. A lot of things in tools that can be happening. For example, 2 or 3 years ago, our large language model has a knowledge cutoff point. But now, because of tools, because they can access web search, weather or financial APIs, they are able to get data that is most recent. We can also, again, 3 years ago, if you asked ChatGPT to do a calculation for you, it's probably wrong, or asked, is 5.11 bigger or 5.3 bigger? It would tell you 5.11 is bigger, something like that. But now, if they understand that they should use calculator or code execution or other customized functions, they'll use that and give you a correct answer now. For 2 years, we are also very obsessed with RAG. We just had the RAG session 1 hour ago, and so we can think of RAG as just one part of the agent tools that is here. That's a document search. Examples of AI agents can span across different industries, and most common one would be customer service, marketing research, financial research, or creative side such as social media campaigns. And one of the most valuable part would be things like agentic coding tools. Okay.
So now that we have a good understanding of what AI agents are, maybe let's dive into what are the different type of agents, what do you call an agent, right? So how do you actually get started with building them? So if you look at the chart over there, so you have multiple, you have simple reflex agents, model agents, goal page agents. So I think the first step is to kind of figure out what kind of agent you want to build. For example, a simple reflex is just an if-else statement, right? Set the temperature to like 100 degrees and boy. But like I think the idea is all of them are actually termed agents, but then you need to figure out. So if you have a model-based reflex agent, so then it's something like, let's say, a robo vacuum cleaner. It has a model, it's learning from its surroundings. Then there are goal-based agents that are like search and planning. Then you have utility-based agents. And then what comes down to what we are focusing on is like learning agents and hierarchical supervisor agents, right? So how do they differ? So they interact with the user, it learns from the surroundings. And hierarchical and supervisor, pretty much what we're going to be doing in today's tutorial is like you have one high-level agent, and then it kind of talks to different sub-agents, and each sub-agent has different actions that it performs, and then they all collaboratively are one big AI agent, right? And now that you have so many, which one to choose? Honestly, I was figuring out which one to try out for today's tutorial, and by the time I read the documentation of one, the new agent came up. A new framework came up, so I just gave up. So, but for today's thing, we're going to be focusing on LangChain and LangGraph, which is, of course, like the most popular ones. So let's a little bit dive deep into what's the difference between these two and how they work together. LangChain, if you've all heard, is like you're basically chaining LLM operations. So Krishnan mentioned about what an LLM is, right? So if you want to chain them and like work, if you have a sequence of functions, for example, you want to retrieve certain data, you want to split some text, you want to do summarizing, and then you want to generate some response. You know there is a fixed sequence, and you know the sequence of tools or actions that have to happen for your use case, right? So that's exactly when you start using what's called as a LangChain. The one major benefit of LangChain is modularity, right? You can mix and match LLMs. You don't have to use the same LLM at different stages. You can, for retrieval, you can use something else, and then for maybe summarizing, you can use something else, whatever works best for your use case. LangGraph, on the other hand, is built on top of LangChain. So as you can see the picture, it's like, think of it as non-linear workforce. Think of it as directed graphs where each one interacts with each other. So there are different nodes, and each node is connected to each other by edges. And then, so here you have multi-step, you have multi-agent, you can go back, you can go, go forward, go back, go left, go right. So depending on different kind, there's like feedback loops implemented. So it's a little more complex, but then I would say it's also definitely more low level because it gives you the freedom to like build the agent the way you want to build. And I think the other key aspect that you need to know here is what is called as React, and this is going to come up in our tutorial. So it's called reasoning and action, right? So when you instruct agents to think and plan after each action, so that's called React-based reasoning. So you think, you act, and then you observe, and then you implement. So now that we know what agents are, maybe let's dive deep into what single multi-agents are, and Asta will take you through it.
Okay, so all of that architecture, all of these different types of agents, you can either broadly split them into single agent as like one agent doing the entire task, or multi-agent. So you can have multiple different agents communicating with each other. So this is a broad framework of how a single agent looks like. You have a user that's interacting with the agents. Agents take in prompts, they have memory, and there can be multiple tools that we can have that the agent can access depending on what the task is at hand. So the one major drawback with single agents is you can see like tools can go up till n. There's no limit as to how many tools you can add. But the agent starts getting confused as the tools keep on increasing as to which one to call for what task, and the separation kind of starts getting blurry. Does anyone want to take a guess as to how many how many tools are good enough for an agent, and how many you start crossing into that blurry boundary? 20, that's a good guess. A little lesser.
7.
That's actually a really good guess. So 5 to 7 is good. The moment you start entering the range of 10, agent will start giving you like weird answers that would not exactly act the way you want it to. And one of the main purposes of agents is to have a good control flow of application so that you're giving it some autonomy, but you're also controlling some of the flow. So too many tools can cause that problem. Think of like if you have an issue with your credit card, there's like a fraud department. If you lost your card, they might direct you somewhere else. If you have issues with your credit card benefits, they might have a different department that addresses those issues. It's exactly the same thing with an agent. If one agent is trying to address too many things, the context can grow by a lot, and it can start getting confused and giving you weird answers. And then the multiple specialization is when you have agents, you can have like a researcher agent, you can have a market analyst, you can have a financial analyst. So every agent can have different tools. The thing with multi-agent though is as you increase the number of agents, there are different architectures that you can have these multiple agents in. So the first one here is the single agent architecture where you have an LLM or an agent and it has different tools that it can access. This second one is a network agent. If you look at this one, if it shows up on the screen. Okay. So every agent on this screen is connected to every other agent. So basically, every agent is able to communicate with every other agent, which is really cool. Like all of your agents are communicating with each other, but this can become really costly really fast. One very good example of this use case is NPCs in video games, where they interact with each other and the game evolves over time, but it can like get very, very costly. This is what you all will build today, the supervisor agent, where you have one main agent, and then think of these like as different sub-agents that are talking to that main agent. And none of these sub-agents are talking to each other. They can only talk to the supervisor. And the supervisor decides which agent to go to next, which you will see in the tutorial that you build out today. The next one is kind of a variation of the supervisor agent itself, but in this one, every agent is a tool. So the main difference, like you will see more as you start building this out today, but think of it as when you have multiple agents communicating with each other in a supervisor architecture, you have a shared memory or a shared state. So if agent 1 responds with something, it adds that to that shared memory that is then accessible to all the other agents. Whereas when agents are being accessed as tools, that is like function calls. You're deciding which arguments are going and which agent sees what. The next one is hierarchical, which is just think of multiple supervisors. So this is your main supervisor that is talking to other supervisors, but then each of those supervisors have their own subagents. And this is like a very complicated architecture. If you want to like have multiple segregations in your applications, then you would go for something like hierarchical. Custom is when you want the most control. So look at this first agent here. It talks to two agents. This one just sends its output to this one agent. And so you can control which agent can call which other agent. And so you have the most control in a custom architecture. We will be looking at supervisor. Some of the things to note when we are looking at building these agents today is they can be something as simple as a prompt and an LLM, which I'm sure most of you are familiar with by now, or it can be something as complex as what Niharika was explaining, which is a React agent. And when we define these agents in our code today, every agent will be like a graph node, and it would decide whether it finishes the task that it has been given or does it call some other agent. And then the last one is the state versus tool calling that I was talking about, which you will see, like some agents we will define today will have tools accessible to them. They will have the supervisor agent that they would communicate with. So you will see the difference on how we are doing the tool call versus how we have a shared memory or a shared state that all of these agents contribute to. And this is exactly what you will build today. So this is the fun part. You will have a supervisor. We'll give you, I'll show up the QR code again, but that'll take you to a Google Drive that has a diabetes data set. And basically you would have three agents, three sub-agents actually, this data analyst, the data scientist, and then the reporter. So the supervisor will get the input and we will ask it to basically do an EDA, build a predictive model, and give me a presentation that I can show to executives. And this will all be done by this agentic system. We will not have any human intervention in building that PowerPoint today. So the supervisor, and we'll show you how that happens, but the supervisor will can talk to like an analyst. You see an arrow that goes to a scientist, and you see that goes to a reporter. So it'll be like, okay, I have a data set. Which is the first agent that I should reach out to? And that would be an analyst. So it will make the analyst call. The analyst will have tools of its own to do different EDA functions. It'll call those tools. The tools will return the results. And then this agent will update the state and send it to the supervisor. The supervisor will be like, okay, now I have the EDA. Next thing I want to build a predictive model. So let me call the data scientist. That's what it'll do. It'll call the scientist. It'll have its own agent, own tools, return everything to the supervisor once the process ends. And then it'll be like, okay, let's build a presentation now. It'll auto-call the reporter. So, okay, fun part. We have an OpenAI API key. If you have it, it's good. If not, we have a video to get that. And then this is the drive that has all the resources that you would need.
But before we transition, we are going to try to fix the issue with the resetting.
Okay.
I think the technical support person is outside, so if it doesn't work, I can just ask him to check.
She's the engineer, she'll fix it.
Thank you.
I had a quick question while we're
Yeah, please.
this is just so like when the supervisor agent, like how does it decide which tool to use? Is it some sort of like classification, small classification model or something that is like choosing depending on the scenario that it's in, or like is it just based on like the LLM's ability to recognize what it's seen and choose properly which tool to use?
Yeah, that's perfect timing question, because that's exactly what I'm gonna be building now.
Okay.
You would have like a supervisor, you would have a prompt instructed that, hey, this is your tool. These are the other agents that are available to you. And this is what they do. And it will, from that prompt, be able to understand, and from the user query, and that's where prompt engineering comes in, because if you mess up the prompts a little, it can act a little bit. So that's how, but we will build the state, the memory, the supervisor, and you'll see how it is.
Is the supervisor like built on something that's above and beyond like
No,
ChatGPT?
it
Because
should
for
just
example,
be
like if I asked
sharing from
ChatGPT
this.
to give me a whole presentation, it would be like full of errors, right? So is this kind of like beyond, like above and beyond the same?
Yeah, it's like more of an agentic system. So we are calling GPT-4o in the background. We are also like setting up the graph and everything. We're setting up the different agents. We're setting up like the prompts as to what agent does what role, and that's how the supervisor will basically direct it to different agents like that.
So we might need that IT support guy, technical guy, or person.
Can you help them?
Yeah, we are.
Like after 3 minutes or something.
It's a
But I
screen
think by-
mirroring.
Same one that was plugged in earlier?
Yeah.
So we flip around.
Well, she's charging and then she said just to take it off. And put it in.
Yeah, so this was happening earlier, so probably for the Mac itself.
Also switch to this port.
Oh, sure, I mean, that might work, yeah.
No working. Do we need to go?
It's a commuter slide.
Or did this get switched around at all?
I did start using that because I, oh,
Yep, there you go.
Just need
it's the port, it's the port. It's my broken port.
All right, so you should all have access to this notebook.
Could you go back to the tiny URL for just 1 second?
Yeah.
It's also on the schedule, PyData schedule.
So you have your OpenAI API key, you have access to this Google Colab. One more thing you need if you don't have it already would be a Langsmith API key. So you can go to Langsmith, set up your account there, and then once you're in, you would see like a setup tracing and then a generate API key option there. Or you can go to settings and create your API key from there as well. So, okay, those are the only 2 keys that you would need. You wanna say something?
Скачай, потом коллаб импортируй.
Raise your hand if you cannot get to the notebook or cannot get your API key.
Just. Okay,
And feel free to raise your hand if you need help and one of us will come to you.
yeah. Any point during this notebook. Okay, so this is the graph that we were just looking at. And now we're like at the initial node of the graph, we'll start to set up everything. These are all the libraries that you would need to install. And then we will import these libraries. Broadly, like if you see like the matplotlib and the Seaborn, this is basically for the reporter visualizations. You have the sklearn for the model building, so the data scientists would be using these libraries. And then we have our LangChain and LangGraph ones. I'm not gonna go over each of these individually because we will go over it as and when we use each of the component. And now, assuming that you have your OpenAI API key and your Langsmith API key, what you would need to do is in the Colab, there's this key icon. So just click on that. And then the environment variable, like the OpenAI API key, you can add it in the name and then your API key's value over here. Same thing for Langsmith API key. You add the environment variable name over here and then you input the value. And then you will have to toggle the notebook access for your Colab to be able to access those. So once you have all of this set up, you're ready to go and start running this notebook.
Anyone having any issues?
Do you need the link chain key?
No, just the Langsmith. Michelle, do you want me to disconnect?
Disconnect what?
The screen and then upload the diabetes data set?
Oh, it's just not. It's fine. Is it an upload?
Connecting to your own data with file browsing.
Oh, is the Wi-Fi down? I didn't set those up, so those are there, yeah.
So, add the keys, I guess I'm hoping I did it right.
Yeah,
So
we wait
which
for
one?
this.
Okay.
I get that.
Okay, so. Yeah, but it's not. Yeah, exactly.
That's fine.
Do I need?
Go up.
Sorry, we're having internet issues, obviously, demagogues.
I told you I should have sacrificed to go. No one listened to me.
It's hard.
Go ahead.
That makes sense. Okay.
This is what I. This is what I do when stuff's loading.
Just copy paste it and see if it works. Because otherwise I don't know how. all this happening. I don't do any of this as part of my
Oh,
work.
okay,
I just do
gotcha.
it for fun.
That's awesome.
And see if you still get that runtime error. It's not connecting to.
To the hotspot. You are connected to something.
Oh, everyone stop download. Okay. Oh, okay.
Да. Да. Какой есть третий cell? Это API keys?
That maybe was an issue.
Ты просто вставил свою вот сюда.
Не, нет, смотри. Вот это что делает?
Okay.
Она берет, это как environmental variable fetch. Вот environmental variable. То есть ты, короче, вот так вот делаешь. Ты сюда. То же самое с Langsmith'ом. Enablage, и потом вот получаешь, как оно было.
Or is that something that's already?
Вот так, вот так. Ну, то есть, не, просто имя своего API.
Okay, now they just have to see it.
Да-да-да.
Okay. No, it's not showing up now.
Да, я тоже не знал.
Yeah.
Yeah, that would be interesting, yeah.
like 6. I'm just going to go and put this to give you.
Yeah, let's see what happens, let's try that. It could also be just a fallback.
I don't know why you needed to uninstall it,
Me
that's
too, so I'm
dumb.
not sure.
Okay, so,
Now my
But now I just need to add it.
yeah, so now you're good.
Oh, you can't do anything.
Yeah, my
Three. So you need to,
externally,
Oh, and I already
and
have
so
them.
I just didn't want anyone to see the
I
password.
launched my VM in Azure.
And
Oh,
put it
there you
there.
go,
So
that's,
then it-
see,
it's
that's
under
smart,
secrets,
that's smart,
It's my own VM.
perfect.
Hey, I'm so sorry.
It's
we're-
okay, it's just not in the same hole as before
I've tried-
where it
yeah.
was, right?
Yeah.
You can't plug it into the other one?
I tried both.
Okay,
Just
so the
now.
one that was working just for a second.
This one.
That was the one that was working before?
Well, both of them were working at a certain point.
Okay, now none of them are. Do you have another USB-C on this side or?
No, it's the only. Let's see. Can we do screen mirroring at all? Like
No,
screen
I'm not
mirror?
sure, you,
Yeah, I can
Discord,
help.
yeah, alright, let's see. Man.
Yeah, right, you're ahead of it already.
that's good.
it probably won't let me copy. Let me go back to the.
I don't know
Oh,
if
it did.
No, I don't, maybe.
when it's
It's fine. I will.
Alright, so but you know, you know.
Now I know what I need to do.
They were both working at a certain point. So maybe it's yours.
Thank you so much. I would
for sure.
not been able to do this.
I mean, it was, it seems like a silly
Very,
problem,
it
but
was very annoying.
kind of like 0 section.
You're not running.
Shouldn't they have their own stuff in there?
Oh.
It's already fine. And now
Oh.
it's.
If you go to the schedule,
I think. So the bottom one should be working more or
I
better.
need to.
It doesn't even show when you plug it in.
Of course it doesn't.
pull from.
The variable has been set.
I don't think it's the dongle because it was working earlier.
Yeah, I think.
It's
like
the
an air-
laptop.
yeah, if
I
you had
mean,
like,
we would need a new laptop basically.
Maybe if you had an air blower or like a paper clip to maybe get in there and see if you can get the gunk out, that might work.
Wait, a hair.
Anyone has a
hair
paper
clip?
clip or a hair clip?
Hair clip, paper clip, pen.
Then
This is gonna go through this.
Actually, a pen might not work. We need like a needle type of situation.
It's gonna.
Paper clip or.
Lines,
situation.
installing lane chain, which is really.
Anyone sew? Oh,
API you call. Rows, importing.
And now just touch it. Alright.
thank you so much. I appreciate your time.
I did nothing.
Let's see what theirs says.
Yeah.
You should all have the same.
You can try to.
Yeah.
I can just add it. It's fine.
Okay. So now that we are back up, there will be a diabetes.csv file that you will have.
Yeah.
And essentially it has like different columns like pregnancies, glucose, blood pressure, etc. And then a final outcome column of a 1 or a 0 predicting whether the person has diabetes or not. So just download this and upload it to your app space. Okay. So we went over the libraries. I'm gonna, yeah.
Anyone having trouble installing the dependencies or anything?
Just us.
If I check every single one of your laptops and they all have the dependencies installed, okay.
No. Okay, let's back up.
I think that's fine. I think we'll just live with that.
Oh my god.
Who put that
We're
there?
doing code changes on a live demo, and Michelle is gonna kill us for this. Okay, so now coming to setting up the state. Okay, let me go back to the chart where we're here after all of this. And we're setting up our initial state. So basically calling all the libraries. The first one is setting up the LLM. So we're using OpenAI's GPT-4o. So that's the LLM we set here. And then we set a class called router of type dit. So essentially, the router is not like an agent of its own, but it is a node. And what it's gonna do is it's gonna route from an agent to another agent, and it's gonna make sure that the routing is limited to something like analyst or scientist or reporter, or ending the workflow when we are done with the application. And then this is the global shared memory, which is the state that I was talking about. And this is going to be a shared state between multiple agents. So over here in the states, we will define messages as one key. And what this does, the annotated list messages, is essentially every time an agent responds or a tool responds, we are going to add those responses into this list. So this is essentially going to create a chat. So when my supervisor goes and says, hey, data scientist, you need to do this work, it has all of the chat history that was there between the supervisor and the data analyst. The next one is basically gonna set which is the next agent that I need to call. So an analyst, because it's a supervisor mode, and all the sub-agents are gonna call the supervisor, but a supervisor can have an analyst or a scientist. So whatever that next agent is gonna be defined here. And then this is the EDA images. So you will see this more when you start building your analyst agent. But essentially what is going to happen is the data analyst is going to do EDA, right? And it's going to build histograms and other graphs that you then want in your PowerPoint presentation. So how is the reporter going to know what these histograms are if they were designed by the data analyst? So that's what this EDA images is going to help you with, where all those images are going to be in a shared state that can then be used by the reporter. So this is like the initial setup, and now we are ready to set up the supervisor. So for the supervisor, we're going to have a list called members, and we're going to define all the sub-agents that the supervisor can talk to. So it's going to be analyst, scientist, reporter. We know that. So then the supervisor agent prompt. This is where we are going to define what the supervisor is doing. So the prompt that we've defined here is, you are a supervisor tasked with managing a conversation between the following workers. And then we have these members, which we listed before. Given the following user request, respond with the worker to act next. Each worker will perform a task and respond with their results and status. Analyze the results carefully and decide which worker to call next accordingly. And then the next few lines basically tell it what these different members are. So we say, remember, analyst agent can do exploratory analysis, scientist can build predictive models, and reporter can build presentations for executives. When finished, respond with finish. So now that the supervisor agent prompt is done, remember we were talking about how each agent would basically be defined as a node? That's what we're gonna do here. So we're defining a supervisor node. The input is the shared state. That's what the agent can see. And then what it returns is a command object, which basically tells what agent to call next, and it's gonna update the shared state. So we prepped the prompt here with messages, role is system, content is the supervisor agent prompt, which we just defined here. And then we add the state messages. Now for the response, we here, like let's look right to left. So we are invoking the LLM with all the messages that it sees so far. And then we have a with structured output. The idea of this is, as you all know, LLMs can be chatty. The response is textual, it can be in any format, and we want it to give us a very structured response so that we know exactly which agent to call next. So if you look here in the comment, this is like an example of an output that we would get, next : analyst. And that is exactly what we can extract from the response for this go-to field. So that's the role of with structured output. So we invoke the LLM and we force it to give us a response in a very structured output. And then it's very simple. We just pick that agent that it responded with. If it said finish, then we end the whole process and it's done. If not, if there is some agent that it asks to go to, that's what we go to and we update the state. So this is the initial supervisor setup. And now we can like start building all these different sub-agents. Niharika will take over.
Can I ask one question? Sorry. So the router we defined a pretty linear path, right? I think it was
Scroll up.
Where the state's defined.
yeah, analyst, scientist, reporter. So is the supervisor actually, is it just basically going through that list in order, or is it actually making a decision based on the user prompt as to which?
It's gonna make the
It's gonna
decision
make that
based on the
decision.
user prompt and the supervisor
Okay,
prompt.
okay.
So
Thank you.
so the purpose of this is really just to constrain
Constrained
one of
it,
those
yes.
four.
So
Okay.
like it cannot respond with something random.
It totally
Yeah.
off base. Okay, perfect.
You have a question?
Yeah, just a quick one about the supervisor prompt. How are we guaranteeing that we're always gonna get that next string, that we're always gonna get that finished string in the end if we're not like specifically defining, you know?
Specifically defining what?
So I
Yeah, that
think
we're
when you
not-
sorry.
Go ahead.
I think when you define the actual state graph and build control the edges to the tools and the nodes, then that will kind of determine when the one step is done, will it need to finish or will it need to go on to the next one? So it will
So
only.
right now we are like building these pieces separately and then we'll connect everything together.
I see.
Does that answer your question?
Uh,
Okay.
It'll get clearer as you
Right,
start like
absolutely.
building these different components and then we like, right now we are just defining nodes and then we'll add edges. That's where we connect
in
everything.
the edges, okay.
edges, that's
okay,
where it gets.
Okay, understood, thank you.
I'm curious about the structured output section there. What sort of structure do you have?
Sorry, could you?
Structured output section, it says LM with structured output.
This one.
Yeah, I'm just curious, because a lot of times I just get string back when I call LLMs. I'm just curious what that becomes.
So that's just gonna make sure that if you look at the supervisor prompt, we are basically asking it to respond with what agent to call next, right? Is it an analyst or a scientist or a reporter, or do you want to finish the process? Now the LLM by default would be extremely talkative, chatty, and it can like give you long text. So the only purpose of that with structured output is to make sure that we get a next : analyst name or a scientist name or like whatever agent you want to call its name. And then we extract it in the next step. So we are only able to extract it because we are getting the structured output.
Great question.
Let's move on. So now that we have the supervisor, let's try and build like individual sub-agents, right? So this is your core chunk of analyst, scientist, reporter. So before we do that, okay, this is machine learning's data analyst 101. So I'm not going to get into how you generate histograms, but just for you all to run through, we're just coming up with certain functions, which is like you generate histograms, you're giving like some image directories. If you see you're like saving, you want to save those histograms in like certain paths. So that's what is being passed here. There's a generate correlation heat map. So these are just functions that will help you in the EDA process, the exploratory data analysis. We can come back to this when I actually call them, right? So what we're doing now, so if you see here, so we are building analyst and specifically we are building tools. The reason I need to build the tools before I build the agent is because when I actually run the agent code, it needs to call the tool. So we need to have the tool defined, right? So what's the tool, right? So it wants to perform exploratory data analysis. Now, what consists of that is that you read the data set, which is already in memory, diabetes.csv, I'm reading it as a data frame. I'm running some statistics. I'm just checking what the basic stats are, whether it's missing some values, any analyst in any firm, kind of what they do. What's the column distribution, the different, and this is where the functions that we generated, like the generate histogram gets called. And what it does is, so one key thing to note here is this, it generates the images, it saves the images in the path that we have given here, image directory. And we want to be able to also keep a account or keep track of these image paths in a list. The reason we want to do this is, like she mentioned, we want to move it in through our state from the analyst to the reporter, right? So then you have the correlation heat map, and then you have the generate box plots. So these are just, you can play around with this. This is just some few examples of EDA that we have come up with. But then the key thing here is that this tool returns a dictionary, which consists of your basic stats, it consists of your missing values, and then it contains these image parts, right? So let's maybe walk with me so far. Okay. This is important for the next agent where there are a lot of question marks, and we're going to like fill in the blanks and see how you all are going forward with it. Okay. So now that we have our tool ready, let's build our sub agent, right? So how do we do that? Now, if you remember in the slides that we had, I introduced a concept called React, right? Reason and actioning, right? So that's something which is the first step here, which is called as a create React agent. Now, why this is important, and to your question about whether it's literal, right? And whether it's, yeah. So this is where it's not literal, because you're giving a React agent to an analyst agent and you're giving context. You're giving context saying that you are a data analyst, you take an input CSV file, you do exploratory data analysis, you do not build any predictive models. So the scope of the analyst agent is only EDA, pretty much, right? And once your task is done, you report your results back to the supervisor. So this is important. So this text and this kind of prompt that you're giving to the analyst agents is important, which is why if you play around and you don't give the right prompts, the LLM and the agent is not able to call the right agent, right? So you create a React agent. So it takes in it takes in a bunch of parameters, but the three main ones that you need to set up an agent is one, the LLM itself, right? Second is the tool. So here, if you see, we are calling the perform EDA. So this is the same perform EDA that we defined here. Also one of the reasons why I had to set it up first. And then you're giving this modifier. Now, if any of you want to like know more about what this creator agent is, there is like a paper established about why it's, why we want to do like a reasoning and acting. Of course, there are agents which do not need reasoning and acting. You can have agents that directly just call a tool or just call an agent. So then you would build a different type of agent. So the create React agent here shows that, okay, we want to build reasoning into our agent, and that's the type. So now that we have that, we then come to the fact of building nodes and edges, right? So now that you have your agent, we want to build the analyst node. Now, two things that the node needs. One, it needs the state, which is pretty much what's transferring from one, agent to another. So it takes in a state. And then what it does is, this is kind of telling that, okay, it needs to talk to the supervisor. So like we mentioned, an analyst doesn't talk to a reporter. The analyst doesn't talk to a scientist. It reports back to the supervisor. So that's what you're defining here. And the invoke is pretty much similar to what Asta showed in the previous one, is that the analyst agent here is invoking and passing the state. And what you get here is the result. Now, we cannot run this immediately here, so which is why I've commented out, but to just give you an example of what this result looks like, because you would need to have that intuition before we actually get into this weird looking regex and why I had to do it. But I don't know if this is clearer. Okay, but you need this because, is that clear? Okay. So what it does is like she said, AI agents are chatty, right? So this is the entire result of what you get when you invoke an agent. So you get messages, and then you get three main messages. You get something called as human message, and there's a bunch of content. And then you get something called as a tool message, which is, if you see here, is the exact dictionary that we returned. Right? You see the dictionary of basic stats, you see all of the stats here, and then you see correlations, and then you see EDA image paths here, and the list of image paths. So these are all the paths. So the tool message is exact hard-coded dictionary. And then this is the AI message. So if you look at the AI message, it says, here are the results from the exploratory data analysis on the diabetes data set. And we have not hard-coded this. This is from the LLM. This is the response. And it pretty much gives the exact same response, like the standard deviation and et cetera, et cetera. And then it says, if you need further analysis or a presentation, please let me know. So you can see the difference in how an AI message content gets generated versus a tool's message versus this human message, which is exactly what we entered, right? This is the prompt that we entered. You read the data set, exploratory data set, etc. So this is basically what we are getting out of it. Now, the reason I had to do so the reason we had to do this is because we want to be able to pass the image paths from, we want to add those image paths to our state. Now that's pretty much what I'm doing. So I'm iterating through the result messages. I'm just finding the one which has a tool message, which has the exact path. I mean, I had to do some rejects and some cleanup because there were some numbers, and that's and then basically what we're doing is extracting this image paths, right? And then returning, so the entire game is about updating the state in the right way, right? So here, when you return, this is similar to how the supervisor did the return function. So you're returning what? You're returning the state. What you want the state to do, you want to update the state. Now, two things that you're doing when you're updating the state is you're sending the messages and you're sending the EDA images. So if you want to circle back to the state, just want to quickly go through here. This is the state, right? So every time we go back to the state. So it's the game of how you play around with states, pretty much. So what you're doing here is you're updating the state, you're sending the messages, and what you send here, this human message content, result messages -1. So the result messages -1 is basically the AI message part. So that's the reason why we wanted to show you this. So the -1 is obviously the last message in the whole output, which is your AI message. So you are feeding this LLM generated AI message as what? You're feeding it as a human message. Now, why do I need to feed it as a human message? Because each agent is talking to each other as if it's a human conversing, right? I cannot feed it as an AI message. Then it would just act as if a machine is talking to a machine. So the trick here is you are sending this content, the AI message. So this AI message content, which is basically from analyst, is being sent as a human message. And along with it, you're sending EDA images so that the images obviously get transferred. And then what does the go-to signify? What's the next agent that you want to talk to? So that's supervisor, right? So this summarizes what an analyst node does. So it wouldn't be invoked. Okay, my LLM is not defined for some reason. Maybe I have to run that. Run all of them again. Yeah. Okay, I think now let's hope it detects the LLM. Okay, it did. Okay, awesome. So that's with the analyst agent. Okay. Maybe any questions before we move on to the supervisor? Yeah.
So you have go to supervisor, but you also have the next in the state. Why don't you use next in the state instead you're using go to supervisor? Because you could go ahead.
So the next is actually for the supervisor to decide which sub-agent to go to next. This is for the state, the actual lang graph state to go back to the supervisor. The actual next router is only in use inside of the supervisor. Does that?
Yeah, so if you see here, it says command update next is actually referencing to the go-to, right? So we're only setting the go-to. If you set the go-to, the supervisor reads the next, which basically, I mean, A is equal to B, B is equal to C, right? Like, you get what I'm saying? Next
so you
refers
are
to.
setting next to actually to go to.
I'm setting the go-to, and supervisor listens to next, which refers go-to.
So next is equals to go to at the end of the day.
As you can see,
When it's in the sub-agent, it has to know to go back to the supervisor so that the supervisor knows to use the next as the go-to. I hope that answered your question.
I mean, it
And please
seems
come
at the
talk
end
to
of
us
the day,
after
next
if that
is
didn't.
go to, but yeah. Okay.
Sorry, what?
Yeah, it seems like go to and next are the same thing. like, based on that code you guys just showed, I was just like, wondering what's the difference. That answers the question.
Okay. Yes. Sorry, yes.
So for the LM dot with structured output function,
Okay.
the output was one of those the AI output that you just showed us that had the.
So we might want to wait until the Langsmith view, because that might answer your question a little bit better.
Yeah. Go ahead.
There you go.
I was just trying to clarify from those outputs that you showed us.
Yeah.
Like with our prompt, was
Yeah.
one of those outputs from this like structured output function?
Those outputs are from this one. When you invoke a message, so agent analyst agent dot invoke. That's the one that gets you the AI message, the human message, and the tools message.
Okay.
Right, and what like she said that what you want to see from the structured output, we'll actually show you Langsmith, which actually shows you individual like what outputs come out from that.
The output that we showed was an example of invoked, but not necessarily of invoke with structured output.
Okay.
But you will see that once we get to the Langsmith overview.
Yes.
In this case, the supervisor knows the results are critical penalties, so it will not send back penalties, right? Does it know where it's coming from?
It would know, right? That's how you're sending the name analyst here. So for example, I'm an analyst node, so I'm actually sending the name here which says analyst. So it knows it's coming from analyst.
So there's no way to send back penalties.
I mean, it could if your prompt is in a way that you say, oh, I want to send it back. So it's again prompt engineering here. So if you want to send it back, you can prompt it that way. That I want to. Let's say you have two analyst nodes, for example, right? Let's say one is doing some data processing and one is doing EDA. You can always send it back with different data. So it's more about the prompt, and then this is just defining like the state,
source,
right? The state of like what's the go-to and what's the update message and what's the message that needs to send. And this message keeps getting updated. Every agent, it doesn't overwrite it, it keeps appending to this, and then obviously the reporter has the full context.
Also, supervisor will make the decision whether what it got from analyst was good enough or not. If not, for the user query, it'll send it back. You can also have agents calling themselves. Like you can make it as complex as needed.
Okay. So the next one is the scientist agent, right? So scientist agent, similarly, we want to build a tool, and then we want to build the agent itself in the node. Quickly, so we just want to build a simple classification model. So if you see here, train model, it reads the data frame, it does a random forest classifier, and then it comes up with these performance metrics. Again, very similar, same pattern as the analyst agent. You have the model results, which is kind of in a dictionary. And then, quiz time. So this is where we are actually doing create React agent, which is the same as we want to build the agent, right? So you call the LLM and you call the tools. Any guesses as to what needs to be in the tool? Train model. 100 points. Okay, and then similarly, you have a state modifier here, which says you're a data scientist. So you're giving the prompt for each of it. You take the input CSV, you just build the predictive model. Similarly, you build the scientist node. So here again, it has access to the state. It can only talk to the supervisor, what we're establishing here. Any clues as to what needs to be invoked? What you need to send? The state. Excellent. Okay. Experts now at this. And then once you do return AI, so again, what you want to return is that you said return command, you want to return the entire state, and then you have update messages. Any clues of what the name should be here? Scientist, perfect. Okay, so because it's a scientist node, and then any clues about where you want to interact with? Supervisor. Okay, we're all amazing. Okay, and of course it did not.
You didn't run the one
I
before.
didn't run the train model.
Yeah.
Okay, perfect.
There's a question.
Yes,
here.
yes,
So
please.
at the top of this scientist agent, there's a list of tools which contains one element, a trained model.
Correct.
And we're telling it to build the most relevant predictive model.
Correct.
So let's imagine we had a train random forest model tool and a train logistic regression tool.
Correct.
How would the scientist agent, where would the descriptions of those tools be specified so that the scientist agent would know which one to pick.
In the state modifier, as
Yeah.
well as in the prompt that you would use to call the workflow.
Okay, so state modifier, you say build the most predictive, you have these options. Random forest, and that's good for this, that, and the other, and logistic, that's good, okay. But it's
Provide
not,
multiple tools.
Yes.
You're not limited to one tool, you can provide multiple tools.
right, which is what I'm asking about.
Yeah, so to
The
answer your
question is, how do you
question,
know which tool? And was there a structured way to describe each tool? Because I think we saw in an earlier talk where there was kind of a structured slot to put the description for each tool. But in this case, it's not a structured slot. You're saying it's just part of this prompt. You're describing the tools in the prompt in this case.
I'm sure there's probably a way to, I guess, have the state modifier be more of a
No,
like prompt.
if you go to the tool, above, there's a doc string there. Do you
Yeah,
see
so
train a random forest?
Right, but does the agent have access to those doc strings just by the
Yes.
fact? Okay, so that's another place.
Yeah.
Okay, the tool, you have the tools as a function, but the function has a doc string and it can kind of look
Yeah.
into that. Okay.
yeah, and
Okay.
it's a list, right? So I can always say train.
Also within the LLM decisions, or like the agent is using an LLM as the background to make the decision to which tool to use.
Right, but again, the question was, how does it know the information about the tool to know?
I got your
Right.
question, yeah.
And so it's either the doc string and or this prompt that you're giving.
Exactly. So it'll take that, and then it's also like here you can actually separate it like train model random forest, and then
Yeah.
you can always call. But you're right about the fact that how it's going to understand. So the doc string would help, and then the state modifier would also help.
Is the doc string kind of good enough, probably?
I think more than that, it would. I think the state modifier. Let's say you put things like you are expected to call a train model random forest, and you're expected to call what do you say, an XG boost as well. Would help you, connect both of them.
Okay.
Is my understanding? Yeah.
Please come talk to us.
Okay.
I'd like to hear more about the other.
Okay, and then so once we do have the scientist sub agents, Chuksan, do you want to take up reporter and then tie things together? Okay.
Okay, let's finish up our final agents. So we're here, the reporter sub-agent. Again, we want this reporter to make a PowerPoint presentation for us. So the first thing we need to do is define a tool called presentation. Okay, so the codes are long and we will briefly explain it. So this thing builds, so this tool builds a PowerPoint presentation with a background theme. It takes contents from the previous agents, and then it takes image paths. Remember, our analyst agent makes some visualizations. And then a theme path is optional if we have, for example, every company have their own templates and they want to use their templates. So that's something you can use. So I'm just gonna quickly go through it. So this tool will add a title slide that has the title, for example, for our prediction. And it would add content slides that our AI agent predicts diabetes based on patient health records. And it will save this presentation in a file path. Now we need to save this, right? Because we want the supervisor to know. So the reporter is a direct report of the supervisor, and the supervisor needs to know where the deliverable is. So file path is very important. Okay. So this tool returns three things: a status, success, a message. For example, presentation is done at a certain path, and then the path. And this is just another example how you can make a structured output. Okay. Now once we have this, we remember to run it. We can finally create our reporter sub-agent. So here, if you're here already, you see a lot of question marks. So here is time for you to put in to the correct answer at these question marks.
Raise your hand. Oh, sorry.
Already done?
The presentation, sorry. Some people are still thinking, okay?
Take your time.
No, please.
Somebody said presentation.
I was gonna say, is it presentation?
Yeah. representation. Okay, that's correct. Then here, reporter note. Last message equal to state messages, and then this question mark should be.
Raise your hand.
Okay, image paths.
If anyone knows, they can say it out loud. No? No guesses? I'm gonna start calling on people, right?
So this should be EDA image.
I mean, she was typing it.
Okay. Okay. So reporter input is create a presentation with the following contents. The first thing is last message. The second thing is image path. So now we have both of them. And then we create a modified state that is a copy of the states. And then we append human messages content equals to
No? Okay, okay. Oh, wait.
reporter input, yes. So this is the message that we give to the reporter, right? Yeah. Okay, and so image path equals to, I think we just have that, it's the image path. Okay, so now reporter agent invoke question mark. It should be the state, The modified state, we created a copy of the state, yeah. Okay. And once we get the results, we should return. First part is the update, the second part is the go to. The update should be, okay, this one should be -1. Oops. And then go to should be,
The name part.
oh, name also has a question mark, okay. What does this message come from?
Supervisor?
Not yet. This is the update, we're updating
So what is
the,
the name of the actual agent that is running this?
He said,
Scientist.
that is.
okay, and it goes to supervisor.
Those two? You know.
Supervisor?
Okay. All right, so we're done with all of our agents. We can finally build our graph. Before, let me add some cats. Where's my cat?
It's incredible. There's corgis.
All right, step 6 graph, we're now here. So we can now finally put all of our graph together. There are lots of question marks, so let's go one by one. Start, builder at edges. So the first edge should be from which one to which one?
Supervisor to analyst.
Actually, before supervisor, we also have start, okay. So it should be start to supervisor. Oops. Okay. And then we'll add all the nodes that we defined as agents. The first node is supervisor node. And so from the second to the fourth should be, okay, this one should be very simple. So the next one is analyst node. scientist node, and reporter node. And is it good? Okay. All right. Okay, so we're done. We can compile and visualize. So everyone should be getting a graph. Okay. Now we're finally at a point where we can call this multi-agent system function. So this function streams the response of the land graph multi-agent system given the user prompt. It basically takes two input. The first input is the prompt, and the second is the agent, which is this entire graph. We have input data, that is the prompt, and then we have a configuration, recursion limit equals to 20. This one is to prevent infinite loops by limiting to 20 steps. Basically, the agent cannot keep talking to each other for forever. Once 20 conversation is done, they have to stop. Okay, so then we can start streaming using these inputs. So input should be using input data, and configuration should be using configuration. Input data. Okay. And then we can, okay, so finally we can call our multi-agent system for our job.
I have the, oh, you guys can copy just from here.
Oh, we already have the answer on the screen. That is,
It's an open book exam.
Yeah, that is read the data sets from CSV, do EDA and build predictive model, and then create a presentation. So when we have the query, then we can call multi-agent system with the graph and the query. Do you think it's gonna? Oh, it's happening! Yes.
Please clap.
Okay, so it calls EDA, makes all the graph. You see the I don't see the EDA images shows up here. You see all the pictures, and then the presentation is also here. Okay, so we are done.
Before we move on, does anyone have trouble getting to this point? Did anyone have any? Okay, can you guys? Sorry, too many hands.
Queries.
Query? Yes. The actual prompt that you would feed into the workflow.
Yeah.
This one.
And you feel free to experiment your own query to see at what point it start becoming not working.
And I'll read it out loud just for everyone. Read the data set from the CSV, do the exploratory data analysis and build a predictive model, and create a presentation for executives. So that is the.
If you just split the query to read a data set and do exploratory data analysis, you'll see that it'll just call the analyst agent. Like it would actually not do the other things. It'll stop after the analyst agent.
Or ask some random things and see what it happens.
Okay.
But it's untested, so that's you have to figure it out.
Sometimes it can behave strange as well. Like
I did see that some other people were having issues. You wanted the query. I think you guys in the back had your hands raised. Did you have issues?
I had a 429 issue. But I think it's because of the API.
It's the quota.
It's the quota.
Yeah, so it's not your fault.
Yeah. Okay. You would have to put in some dollars there, unfortunately.
Need help or you have a question?
I just had a couple questions.
Sure. Okay. Yes, please.
So the tool decorator is the.
Everyone, sorry.
No,
Can we calm down for a second and let the questions?
Yeah,
Okay.
so that's the part.
The tools decorator, is that Langsmith decorator?
No, so the tool decorator is actually from LangChain,
Sure.
not LangChain.
Sure.
And it's like,
LangGraph.
depending on.
If you go all the way up to the top where we're doing the imports,
Send out the
you can
cost.
see that it's,
Oh, okay. And is the I guess like the description, it's describing it as a decorator? Like if you
sorry, you're saying,
do like a help function, like when
you're
you
saying
look.
this decorator?
Yes,
If I
yes.
did a help function on perform EDA. Or, I'm not sure what that.
If you do a help function trying to like understand what the tool decorator is, would it showcase it as a decorator?
Yes,
And
yes.
there should be a
So I
pricing.
believe that the tool decorator is what LangChain uses to be able to kind of take it like as the next step in the chain. So when you define a function, obviously you have your function definition, but that has to be also put on top of some of the stuff that LangChain will use to input like the next step. Does that answer your question?
Yeah. Also, we defined the start, but we didn't define the end.
So,
It's on.
Yeah, so you've done that.
What is missing?
Ah, okay, understood.
The reason is that you just.
Thank you.
you'll have to
Cool.
essentially fix your-
I think he had his hand up first. Please go ahead.
It's not, the problem's not you. really.
Sorry, can we just quiet down a little bit? Sorry.
Show the add edge line in the way end again, explain what it does when we're creating the graph.
You're saying this. So when we, does that answer your question? Just showing it, or should I? Yep,
So I have a theoretical question. You were doing random
I have a
forest.
theoretical answer for you.
You do a random forest classifier here, you know the shape of the data, you know the shape of the output. Let's say that you don't know the shape of the data, you don't know the, output parameter, which is the Y.
So I think just because of it, in the interest of time, and we do have a demo to go through, I would love to talk after this. I think that's more of a, that's maybe more advanced than the point of this demo,
Okay.
but you guys can answer.
Yeah, I think we just have less than 15 minutes, so
Yeah.
we need to.
But please, if you wanna ask your question,
Yeah.
just so.
Sure, I was
we
just
can
wondering
after.
if it was, unknown type of data, unknown shape of data, how would you do it? Like, what would you, are there any
Yeah,
research?
so maybe you have a tool that's like a data processor that would give you all the columns, all the data types and stuff, and then that would feed it into the data analyst. Does that help?
Yeah.
Can I swap the GPT model to something like an Olama, Llama 3.1?
Absolutely. You would need an API key for that, right?
Sure.
I think just because we had the API keys available for OpenAI, that's why. But it's configurable based on this LLM object. So you can see that LangChain comes with OpenAI integration, but it also comes with Olama integration, Claude, and others. This LLM can be not OpenAI. You just have to define it yourself and have the proper access. Any other questions?
I'm still curious how we force the LLM to give us a response in like the format that we want, and if like sometimes, maybe depending on the user prompt or whatever, do we get like a bad response, and can that mess up the
I love your
agent work?
thinking. You're thinking about the edge cases and
Yeah.
everything. I think that for the interest of the time, since we do have 2 more things to go through, we will talk to you after.
Okay,
How about that?
sure.
Or you can experiment with it and let us know next
Okay,
year
maybe I'll do
at PyData.
that.
Okay, any other questions? Anyone need help?
Okay, any other questions?
We'll take it later because you want to do your lines.
Okay, so now that these, no.
Okay.
So now that these lovely ladies have built, the best AI agent workflow, everyone's trying to give them $1 million. They are not trying to send every single person on Earth a collab or a QR code, right? They want to be able to deploy it to the cloud, have it be more stabilized, have it be more modular, have it not be all in one file. And so that's kind of where I come in as the backend engineer or the data engineer to be able to make this production ready. So there's 3 components. to kind of where we would start doing it. We're not gonna be able to deploy to the cloud during this, but we're gonna set up the steps so that when you do want to deploy to the cloud, it's a little bit more ready than in the collab. So the first step is source control. So you see here, it has build data science agent. If you look at our actual Google Drive folders that we're not sharing with you, it has V2, V3, V4, you know, so it's very hard to kind of make changes and then like get the version history. So that's why we go to version control. So we actually have a repository where this code and some of the demo stuff is part of. Some of the code that's actually in this one, because I implemented a code freeze and they didn't listen to me, will be up later today. But as far as you can see, we have the packages, so we have the agents, we have an API, so that it can be like, there can be an API-based version that you don't have to actually call the agent, an API will call the agent. And then we have a agent UI, which is built with Streamlit. So the first step is source control, getting your stuff into source control. Anyone has access to this repo, it's a public repository if you want to take a look at it. I would just say that there's 2 branches. We've been switching to using UV. So this UV manager branch is going to be the most up to date and we'll have it be the main branch. Just if you're looking at it. So the second thing that you're going to want to do is being able to monitor and trace your applications. If you have any issues, it's a lot easier to debug. And then that's where the Langsmith application comes in, that we had set up the API keys in integration. For the Langsmith library, anything that you build with LangGraph is automatically instrumented. You would just need these environment variables set up, this LangChain tracing v2, and then this Langsmith API key. You don't have to add anything else if you're using LangGraph. And then we can take a look. So you can see, if we check this default project, this 243, okay. This is the one we just ran in the collab. So you can see I just added those environment variables and then whatever just ran is automatically instrumented so that we can see what the chronological order of this is, and then also the outputs. So you can see here's the human messages, here's the analyst messages, the scientist messages, and then the EDA messages. So you can kind of go through and for each step have more observability over what is happening. And now the demo. So we built a Streamlit application. Streamlit is actually pretty well integrated with LangChain. So they have LangChain's message history callbacks. And also they're really working with building UI elements for chatbots. You can see here, now I don't have to actually, like if I had this deployed on the cloud, I would be able to send a link to this website to someone who wants to use my agents. They would not have to run anything on their actual laptop or know anything really about agents. So how can I help you? I will just put in the prompt that we used in the collab. And you'll see each agent that's called. It's going to be putting in the output here. This is actually something we had before we use Langsmith. So this is kind of what Langsmith does for you, is it will show you the intermediary steps. But if you can see a little bit here, it will be thinking about what tool to use next, and then it will actually call that tool and then show you the outputs. So you can see it performed EDA, trained the model, then the presentation, and now it's complete because it's at the finish step. So that was just a quick demo. And now we will open the presentation. This one actually does have a theme with it. So you can see, oops, mistake, that one should be done. But so this presentation, no human made it. It was all built by these AI agents. And it's pretty similar to the one without that you'll be generating on the collab. It just has the template attached to it. Let's see. maybe a little work. Maybe the agents, maybe need a little work, but the benefit of it is that this was not done by a human. As you work with the agent and make it better, all that, you won't have to ever make a presentation ever again by hand. I think that is the end of the demo. So.
A 30-minute break, so if you want to go a little over, that's fine. Yeah.
This is last conclusion slide.
Where is it? Oh. I like to think it's talking to me about the presentation. So we talked about LangSmith, again, another link chain. Link chain is the umbrella. Link chain has link chain libraries, link graph, and then LangSmith is our platform for debugging, monitoring, and evaluation. We won't get into the evaluation part right now, but you can actually set up different metrics for evaluation so that when you're running, you're running 100 different simulations or 100 different tests for different prompts to break it, then you can kind of know LangSmith is my app or my dashboard for all that. And it integrates with other frameworks besides LangChain. It just requires a little bit more code without the automatic instrumentation. Okay, we did that. And now someone do this part.
Okay. Yeah, so just to wrap up, we know that the AI agent landscape is changing every day. Have anyone heard about vibe coding? Yeah, right. Last night I was vibe websiting. I created a website using Manus. So have anyone heard about Manus?
Yeah, Manus is great.
Yeah. Manus is very autonomous. And then how about MCP? Anyone heard about MCP? Yeah, it's actually not a very catchy name. Model Context Protocol. So it's trying to set a protocol so that it can connect to any large language model in any kind of tool, for example, Google Drive or other tools that you have. One thing why MCP becomes popular is at this point, no one wants to commit to one certain large language model or one certain tool or even one certain framework. People don't want to commit to LangChain, LangGraph, maybe. So Model Context Protocol is like a middleware that tries to satisfy people who don't want to commit. People don't want to commit. Oh, okay. End of presentation.
Sorry. With that in mind, actually something that you touched on, that we can use LangChain and the different models that are out there interchangeably, right? Like it could be OpenAI, Anthropic, but then through LangChain, we can apply the same set of operations on them, right? Agnostic of kind of like the core API's functionality.
Well, yeah, I think that it's meant to be a building block so that you can use it for whatever purpose. Like, it's not meant to give you the exact tool for the right job. You can build upon it, and then I think that's what you're saying, is that you can extend it.
Yeah, right. So for example, like the core OpenAI API is different than the core Anthropic API, but for LangChain, you can switch out, like basically, you can have your entire code, but you can switch out which model you're calling and it will still work, right?
There are a bunch of wrappers. Oh, sorry.
That's what I was saying. The framework is the same. You can switch to whatever model you want.
Perfect. And you won't have to change the
No,
wrapper
because
code.
of the wrapper. LangChain does the work for you.
Perfect. That makes sense.
Any other questions?
We're actually over time, but feel free to catch us.
Yes.
Yeah.
At the after party.
Oh, and we are going to after party.
Oh, where's that?
Posted on Discord.
Kidding, no.